A cylindrical disk of mass m is equal to 1 kg and radius r is equal to 0.15 meters was spinning at omega is equal to 5 radians per second when it was placed on a flat horizontal surface and released. Refer to the figure. Gravity G acts vertically downwards as shown in the figure. The coefficient of friction between the disk and the surface is finite and positive, disregarding any other dissipation except that due to friction between the disk and the surface, the horizontal velocity of the center of the disk when it starts rolling without slipping will be. So we have to find out the horizontal velocity of center of the disk when it starts rolling without slipping. Let's look at the solution. First we will start with writing the given values. We know the mass of the disk, it is given as m is equal to 1 kg. We also know the radius of the disk, which is given as r is equal to 0.15 meters. We know the angular velocity of the disk, which is omega is equal to 5 radians per second. Let us consider the case where the disk starts slipping. In that case, since the disk is rotating in the clockwise direction, when it is undergoing the slip will be usually backwards. Hence, the frictional force is shown to act forward with a right arrow, and let us take the frictional force to be F. Since the disk is spinning on a horizontal surface, the horizontal surface applies a normal reaction R at point P as shown in the figure. Slipping of the disk is backwards, hence we know that frictional force F acts forwards as shown. Now, it is important to understand that the magnitude of frictional force F is mu into R, where R is the normal reaction due to the horizontal surface and mu is the coefficient of friction between the disk and the surface. For force equilibrium, we know that mu R, which is the frictional force, should be equal to m into A. And for the free body diagram considered, the normal reaction will be equal to weight of the disk, which is mg. Replacing that in the above equation, we get mu into mg is equal to ma. From that we get acceleration A is equal to mu into g. Let us assume that after time interval of t, the disk starts pure rolling. Thus, the velocity of center of the mass is given as v is equal to u plus at. Since the disk was initially at rest, u will be equal to 0. So from this equation, we get v is equal to a into t, and a was obtained as mu into g. Then the velocity of center of mass after time interval t will be v is equal to mu into g into t. Let us consider this as equation number 1. We also know that torque about the center of mass of the disk can be written as tau is equal to frictional force into the radius of the disk, and we have the value of frictional force as mu into r, and r is equal to mg. For any member which is under rotation, torque can be written as tau is equal to I into alpha. Now, substituting the values on either sides, we have mu mgr is equal to mr square by 2 into alpha, where mr square by 2 is the moment of inertia for a disk. From this, we get the value of alpha as 2 mu g by r. Let us say that the angular speed of the disk after the time interval t can be written as omega is equal to omega naught minus alpha t, and we have the value of omega naught as 5, and replacing alpha as 2 mu g by r, we get omega is equal to 5 minus 2 mu g by r into t. Let us take this as equation number 2. It is to be noted that for the case of pure rolling, the velocity v is r into omega. Now using equations 1 and 2, we get the time interval t as phi r by 3 mu g. Substituting the corresponding values and finding out the velocity will give us 0.25 meters per second. The correct answer range given for this question is 0.24 to 0.26.